Today's tutorial will deal with section 1.6, still working with solving equations that have rational coefficients in them. And we're going to look at another example of fractions with binomials in them. So this will be fractions, and then with binomials. Okay, so what we're going to do is we'll do an example and work it through similarly as we did with the other rational expressions with fractions. And my example is, for equation A, I have x minus 7 will subtract 2y plus 1 over 5 equaling 0. And then for B, I have x minus 2 over 9 plus y over 3 is equal to negative 2. So what we want to do first of all is find a common denominator here, similar to when we worked with the other fractions. Common denominator that will eliminate the denominator. So find our common denominator. All right, find our common denominator for each equation. So 7 and 5 and a 0. So 7 and 5 would have a common denominator of 35. And you have to be careful in this case. When you multiply by the 35 with this binomial expression, you have to put that binomial expression into brackets when you're multiplying through. So this would become, for A, 35x over 7. Subtract 35 times the binomial expression, 2y plus 1 in brackets, all over 5. And we can reduce there later, which we'll get into, and 0 times 35 is still 0. So we can reduce along. Let's do that right away. 35 over 7 is, let's do it underneath here. 35 over 7 is actually 5x. Minus, 35 divided by 5 is 7, so we can put a 7 in front there. And still keep our brackets there. So that reduces down to just 7 over 1, or 7. So then we can work this out to 5x minus 14y minus 7 is equal to 0. Bring the number over. 5x minus 14y is equal to 7. Okay, so there's an expression for A that has no denominator in it now. So we'll be able to work with that. Now let's work with question B, or equation B over here. So I want to take a common denominator from 9 and 3 and 2 over 1, or 1. So that would be 9, so multiply everything through by 9. Again, being careful so that you include binomial expression in brackets. 9 times x minus 2 over 9 plus 9y over 3 equals negative 2 times 9 is negative 18. Let's reduce here. This will just reduce to 1 times that. So 1 times x minus 2. And this will reduce down to positive 3y is equal to negative 18. Reduce this down to get x minus 2 plus 3y is equal to negative 18. So add 2 to both sides. X plus 3y is equal to negative 16. Now we have our two equations, pardon me. And once we have our two equations and we've eliminated the denominator by multiplying through and being careful to keep the binomial expressions in brackets, we now just choose to use our old method of elimination or substitution. In this case, if I multiply this whole thing, if I want to use elimination, I can multiply b by a negative 5 and then add it to a and eliminate the x. And that's what I'm going to do. So I'm going to use elimination. And I'm going to multiply b by and negative 5 in order to change this coefficient in front of the x to a negative 5 so that I can eliminate it from a. So that's what I'm going to do. I'm going to go negative 5 multiplied by x plus 3y equals negative 16. Keeping that all in brackets because I'm multiplying the whole thing. So this becomes negative 5x minus 15y is equal to positive, well, what do we have there? 16 times 5, both negatives change to positive. That should be 80, right? 5 times 10 is 50, and 5 times 6 is 30. 50 and 30 is 80. So there we have that expression for b. So then we can add equation a, and that'll eliminate our x's. So 5x minus 14y equals 7. Well, this eliminates. This here would become negative 29y is equal to 80, and this is 87. And if we divide both sides by negative 29, we get y is equal to, I believe, negative 3. Let me just do a quick double check here. 3 times this would be 60. Yep, 87. Perfect. So now we have a solution for y. So now we have to find the x. So solve for x. Given that we now know y is equal to negative 3. So I'm just going to check and make sure that's in my field of view. And I'm going to move right up here like this so that we can use this bottom space here to figure out our x. So I have to, our fraction skills are going to come in handy again here. We're going to have to go back to an original equation in case we made a mistake in between and solve for x. So I'm going to use the first equation, which was x over 7 is subtract 2 times y, which would be negative 3, plus 1 all over 5 and that's going to equal 0. So I'm going to work this out to solve for our x. So I'm just going to leave this x over 7 for now, because I know this is going to work out to negative 6 plus 1 minus a negative 5 over 5. So negative 5 over 5 is like negative 1 and minus a negative 1. So we now have x, just try and conserve a bit of space, x over 7, and that would become plus 1 is equal to 0, because 2 negatives there would become a positive. So we can bring the 1 over to the other side. Let me do that over here. And again, I'm just going to check my field of view, make sure we're okay. Yep. So this then becomes x over 7 is equal to negative 1. Okay, so we can solve by multiplying both sides by 7. So x is equal to negative 7. So our solution turns out to be negative 7 and negative 3. Now we should do a check here. I'm running out of space on this sheet, so I'm going to flip over and do the check on the next sheet. So we'll be putting it back into one of the original equations. So I'm just going to do that. I'm going to flip over here. Okay, and we're going to use an original equation, and our answer that we got was negative 7 and negative 3. So, just make sure that's okay.